Welcome back, everybody. In our journey to understand how glaciers shape the Earth's surface, now we have to talk about not just what they take away or erode from an environment, but also where does the sediment go? What is it that glaciers deposit or make, create? I've included this diagram here because it does a really good job of pulling together all of the different parts of this unit. Now, some of the terms here we're not familiar with yet, but by the time we get to the end of this section, we'll be able to go back, look at this, and be able to describe and explain everything that is happening in this alpine glacier system. Okay, so before we get to all the vocabulary and our different terms here, first we're just going to look at what these depositional features look like, right? If you went out into the world, what would you see? So the first thing, right, we have something that looks kind of like a normal hill, not super big, that has been maybe stretched out somehow. Next feature. So this, right, we have this sort of snake-like river of sediment, right? A river has been filled in somehow, right? And we can actually see one here, and we can see maybe a little smaller one off to the side here, right? Kind of a sinuous ridge. We also have this, maybe a circular hole in the ground, depression that has been filled in with water, a hint of how it got there in the background. We also have something that looks more like a normal hill. Not quite a mountain, nothing here that really looks like a fault, just a standard hill. There's not much else to call it. Okay. And we also, looking directly at glaciers here, we can see these different sediment piles that have been created, right? There's some here, there's one here. We can look, we have a sediment pile here, there's one here, another one here, several of them in this photo here. Okay, so now let's get to the terms. Okay, so we have our depositional features. What are we talking about? Features formed by deposition, like creating, making. In this case, we're making them out of sediment at margins of glaciers or as they retreat. We got eskers, drumlins, kettles, kames, and moraines. These are not all the depositional features, but these are the ones that we are going to focus on. Okay, so first are our eskers, right? Remember seeing this sort of long ridge of sediment. And you might have thought, well, this looks exactly like a river that has been filled in with dirt. And that's actually exactly how these form. So glaciers are big things, but sometimes at the bottom there is some sort of a crack or a tunnel, a cavity for water to flow through, right? And as that water flows through it and carries sediments with it and deposits them, well, whenever the glacier goes away, retreats, melts, it's gone, then what is left is just the sediment that was deposited by the subglacial river, the subglacial meltwater. So if we went in, right, we're in Google Earth looking from above, and I ask you to identify the features found in this area. Well, you might point to the lakes over here, and you would be right, but first and foremost, you would look at this thing here, right, our ridge. And I've included it next to the river here, again, just to illustrate the similarities here, right, the path the river takes and the shape of our esker. Now, you might remember, right, we saw a hill at the beginning, right, that first photo that looked sort of like this, right? And this is actually formed exactly how you might think. We have an existing hill, and the glacier flows over it and starts to kind of elongate it, right? It sort of smooths it out, stretches it out. So this is going to be formed by glacial ice that moves over an existing mound of sediment or a hill. So you might imagine, right, that you see an image or you're in Google Earth and you see a hill that looks like this. Well, the question is, where did the glacier move? How did the glacier move to be able to create this? Well, okay, let's look back, right? So we have our steeper side, and then we have our shallower side, and the shallower side points in the direction of glacial flow. So here we have our steeper side and our shallower side over here, so we can be pretty sure the glacier was flowing in this direction. Now, we also saw this sort of circular lake at the beginning, right? And before there was a lake there, well, maybe there was some circular hole in the ground. And this is going to be a kettle, right? The kettle is where you have the hole. When it's filled in, that is a kettle lake. So you might imagine, right, we have a glacier which advances, and later it retreats. And as it retreats, it leaves behind these blocks of ice. And these blocks of ice get buried as sediment is deposited around them, and then they melt. And there is this hole, this maybe circular shaped depression wherever the mound of ice used to be, right? This is how we get our kettle. So there are places in North America, for example in Minnesota, where the landscape is just completely covered with these smaller circular holes which make these little lakes. Now, in some cases, right, in Florida maybe, well, we know how those holes are going to form, but this is going to be a different process. These are going to be our kettles, or filled with water become kettle lakes. Now, there were also these sort of normal hills that we saw in the very beginning, and these are our Kames. So these are going to be very complementary features to the kettles, and the formation of the Kame is very closely related to kettle formation. So it's our same setting here. We have glacial ice, which at one point had advanced very far, and after it retreats, it leaves these chunks of ice behind in its retreat. And around those chunks of ice, we have ponds which fill with sediment. We fast forward, the ice melts, and wherever you have those sediment piles around the ice, those become the Kames. Wherever you had the ice itself, you have a depression there, and it becomes kettle, right? You can see just geometrically that these tend to alternate, right? Kame, kettle, Kame, kettle, Kame, kettle. And so we get something called Kame and kettle topography. These tend to occur in close association with each other. So if you saw something like this, and well, it looks like just a normal hill, you wouldn't 100% know that it was a Kame and know that it formed through this process, but because it is a whole region which has this topography, you would look at the entire area, and if you saw many of these hills and many of those kettles or kettle lakes, then you could figure out the process by which this feature formed. Now, there were also those images where we saw these lines of sediment, not, curvy, sinuous ridges like we saw with the eskers, nothing that looks like a river, but more straight lines around the edges of these glaciers. These are our moraines. We have our massive rocks and sediment. These are pushed around by the glaciers and tend to form at the edges. And there are a couple different kinds we'll talk about. We have our lateral moraines, which are going to occur at the outside edges of a glacier. We have our medial like middle, going to occur in the middle of the glacier. Then we have our end moraines, which are going to occur at the very end of the advancement, the very end of the front of the glacier, including things called terminal moraines, which show the very furthest that the glacier has ever advanced. So let's do an exercise here. I can show you a photo, one that should look familiar, and you have to tell me where the moraines are and what kind of moraines we're looking at. Okay, so what are those types? Well, we have lateral, medial, and end moraines. So let's see. Lateral, maybe here at the edges, and one end moraine here at the end. And that's absolutely what we have. Okay, our next example. So we have lateral moraines at the edges, medial moraines in the middle, and end moraines or terminal moraines at the end. Well, I'm not sure if I see anything that looks like an end here. I see some lateral moraines on the side and maybe one medial moraine here, right? Lateral, and medial. Okay, so we finally made it all the way back. Now we should be able to look at our diagram here and look at every single feature on here and know what's going on. If you want to quiz yourself, test yourself, see if you've really gotten the material, you might try looking at this and seeing if you can explain the terms and what is going on in the picture here. Alright, so let's recap, try to put together everything that we've talked about here using this diagram. So glaciers tend to form in one of two settings. We have continental ice sheets, and then we have these things called alpine glaciers, which tend to form in mountains or valleys. There tends to be an accumulation zone higher up where snowfall is greater than snow melting, and snow accumulates. The glacier slowly moves down the mountain. Down lower is the ablation zone, ablation being the opposite of accumulation. So we have more snow melting than we have snowfall. As it moves, there are a couple different ways that it shapes the environment. We have plucking, where it pulls up big boulders off the bedrock, takes it with it, and we have abrasion, where it scrapes against or smooths out one of the ground surfaces here. It could create a smooth surface, or it could leave things called glacial striations, these sort of parallel lines. We also have things in here which are erosional features. For example, we have something called a cirque, right? So you might call this a cirque glacier, sort of a bowl shape, sort of a basin shape here, except that it has, a side of it where you could put your legs down, more like a chair than it is a true bowl. We have these things called arêtes, where the glacier has eroded on one side until it's a very steep side here, eroded on the other side until we have a very steep side here, and what you're left with is this steep, sort of sharp ridge in the middle. We have more major glaciers, and we have tributary glaciers, which might feed into them, sort of subsidiary glaciers, just like a tributary with a stream. And what else? We didn't talk about crevasses. You don't have to worry about that. We have our depositional features here. So this advances and it pulls back, and as it does that, it leaves behind all sorts of depositional features in the environment. For example, we might have a ground moraine here. So this is going to be moraine, means sediment from the glacier that has been deposited actually as a layer here on the ground. You can see it as the brown. We have these things called eskers, where there was some sort of subglacial river flowing, carrying sediment. As it retreats, the sediment is left even as the river is no longer there, making something called an esker. We have these things called kames, and we have kettles. So as it retreats, it leaves these chunks of ice scattered throughout the landscape. And as sediment piles up around the ice, and then the ice later melts, we have this Kame and Kettle topography. Kame being the hills where the sediment has been piling up, and the kettles being these places where there were ice chunks before it is melted, so there is not the same amount of sediment there. Finally, we have these things called moraines. So these linear features, lines of sediment that is moved by the glacier. They can be lateral on the edge, they can be medial in the middle, or you can have end moraines or terminal moraines, which mark the far front of glacier advancement. Okay, so what are our big ideas for the whole unit? What do you absolutely have to need to know? You need to know those 5 types of glaciers we talked about. In the first section, you'll need to know those erosional landforms, and you'll need to know the depositional landform. That is all I have. For those of you who made it to the end here, thank you.